Hello, everyone. I'm Ametefe Kofi Timothy from the CSIR-Building and Road Research Institute of Ghana. Today, I'm presenting on the mechanical and durability properties of low-grade calcined clay concrete. In this presentation, we will look at the background, the motivation and objective of the study, the materials and methods used, the results, and then discussion of the results obtained and some conclusions that can be drawn from the study. Now, according to the Global Cement and Concrete Association, concrete is globally the most widely used construction material and also the world's most used material in general after water. Its application includes the construction of infrastructure, which is the movement of goods and people, such as roads, interchanges, airports, bridges, canals, etc. Concrete also plays a major role in the generation of hydroelectric power and power generating wind turbines. It is used in the construction of dams and in the foundations of wind turbines. Furthermore, concrete is used in the construction of residential, commercial, and various multi-purpose buildings. Thus, its versatility, availability, durability, and low cost as compared with other conventional construction materials make concrete ubiquitous. However, the manufacture of cement is more energy intensive and greenhouse gas emitting. According to the Global Carbon Project report, China is the leading emitter of carbon dioxide from the combustion of fossil fuels for energy and cement manufacture. So, from this chart, which was presented by the Global Carbon Project, to see that China is leading in the annual CO2 emissions of about 10 billion tons. And this, I believe, can be attributed to the fact that China produces and supplies a lot of clinker to most African countries. Also, according to the Global Cement and Concrete Association, the total global CO2 emissions from the construction industry is about 2.5 gigatons, of which approximately 1.5 gigatons, which is about 60%, is from the heating of limestone, whereas the remaining 40% is from the combustion of fuels used in the cement kiln and other plant processes. The production and use of cement and concrete is rapidly going to increase, particularly in the developing sub-Saharan Africa, as a result of the rapid increase in population, which in turn would increase the infrastructure demand and also lead to urbanization and rapid growth in industrialization. Hence, the exploration of alternatives for making concrete more sustainable is inevitable. Now, supplementary cementitious materials provide a forward-looking approach to reduce the embodied carbon of cement production and consumption. Commonly used SCMs like fly ash and GGBFS will with time reduce due to the transitions also happening at these coal-fired power stations and steel industries. Therefore, materials which are sufficiently abundant to meet projected demands and compensate for the reduced supply of the commonly used SCMs need to be studied. Now, because of the worldwide availability of clays and its low carbon content, and then the lower energy required to activate it, the use of calcined clays is on the rise generally. The main objective of the study is to examine the mechanical and then the durability properties of concrete containing 50% by weight of Portland cement replaced with low-grade calcined clay concrete, calcined clay pozzolan. Sorry. The materials used for the study included Portland cement of grade 42.5R, calcined clay pozzolan, which is being produced here in Ghana by the CSIR-Building Research Institute, potable water, super plasticizer, coarse aggregates of 20 mm nominal size, and then fine aggregates. The experimental program began with the design and proportion of concrete mixes in accordance with the ACI 211.1 standard. The specified characteristic strength and slump range used for the design respectively were 30 MPa and 75 to 100 mm for the slump. So for the concrete mixes containing 50% by weight of clay pozzolan, the water content obtained for the control was reduced by 15% with the help of the super plasticizer. Trial mixes were prepared and necessary modifications to the mix proportions were made until the specified slump range was obtained. 100 by 100 by 100 mm cubes were prepared and used for the compressive strength test, and then the acid attack test in accordance with the BS and the DSTM standards. Prisms were also prepared and used for the flexural strength test in accordance with the EN standard. Also, cylindrical concrete samples were prepared and used for the RCPT. Samples after preparation were stored on the plastic sheet and covered with wet baler for 24 hours before they were removed from the molds and cured in saturated lime water. The compressive strength tests for both mixes were conducted at 3, 7, and 28 days. The flexural strength was also conducted at 28 days. The RCPT and acid attack were also conducted after 28 days curing. Now, the proportions of the various concrete constraints are presented in this figure. Now, from the figure, you can see for the control mix, cement content of 112 kg per meter cube was used, and 50% of that was replaced. It's 206. Now we used 208 kg per meter cube of water, and for the control, and for the clay pozzolan concrete, we reduced it by 15%. The final rates for the control that was obtained from the mix design was 731, and that for the clay pozzolan concrete was 769, just to compensate for the reduction in water in the per meter cube volume. The coarse aggregate content was the same for both mixes, and for the control there was no clay pozzolan, but 50% of clay pozzolan for the concrete containing the clay pozzolan. We didn't use any super plasticizer for the control, but used 6.2 kg per meter cube for the concrete containing the super calcined clay. The slump for the control mix was 95 mm, and then that obtained for the clay pozzolan concrete was 80 mm. So this shows that even though the clay pozzolan demands more water, this water demand can be taken care of with the use of the super plasticizer. Now both mixes attain the specified characteristic strength at 28 days. So from this chart, it can be seen that at 28 days, the control The compressive strength for the control was approximately 34.5 megapascals, and that for the concrete containing 50% by weight of clay pozzolan was 32.2 megapascals. However, the early strength, that's at 3 days, the control mix was about 43% higher than the compressive strength for the clay pozzolan concrete. Nonetheless, it is worth noting that the difference between the compressive strength at 28 days is only about 7%, which is a significant reduction as compared to that of the 3 days. Now, the flexural strength obtained for the control and then the clay pozzolan at 28 days were 5.8 and 4.0 megapascals respectively. Now, the control strength, the flexural strength for the control was about 31% greater than that of the clay pozzolan. But on the other hand, the flexural strength of the clay pozzolan concrete falls between the theoretically stipulated 10 to 15% of the compressive strength. Now, for the durability, the total charge for the control mix fell between 2,000 and 4,000 coulombs, which represents a moderate chloride permeability, while the total charge for the clay pozzolan concrete fell between 1,000 and 2,000 coulombs, which represents a low chloride permeability. The reduction in the charges could be explained to be as a result of poor blockages due to the contribution of the clay pozzolan in the concrete. Now, furthermore, the addition of the clay pozzolan reduced the amount of potlindans, which is calcium hydroxide, precipitated during the hydration, thus mitigating attacks by acids. So from this chart, it can be seen that the weight loss after immersing the samples in the acidic solution for 28 days for the control is about 10%, but for the clay pozzolan there wasn't any weight loss. Rather, there was an absorption of water by the concrete. Now, from these images also can be seen that the calcium hydroxide formed in the control mix dissolved and leaked out after immersion in acid, but then little or no calcium hydroxide was present in the clay pozzolan to be dissolved and leached out. This can be attributed to the pozzolanic reaction between the clay pozzolan and the calcium hydroxide in the presence of water. Now, in conclusion, the use of high volume, low grade calcined clay concrete in the production of normal weight concrete does not adversely affect the mechanical properties of the concrete. Also, the reduction in the ingress of chloride ions in the concrete containing calcined clay pozzolan indicates that the addition of calcined clay pozzolan refines and improves the pore structure of the concrete. Furthermore, the incorporation of calcined clay pozzolan improves the resistance of the concrete to acid attack. Thus, a more durable concrete can be obtained with the use of calcined clay pozzolan. Finally, superplasticizer usage can alleviate the drawbacks associated with the incorporation of calcined clay pozzolan in concrete, such as poor workability, high water demand, and delayed strength development. These are some of the references we used. Thank you very much for your attention, and thank you to the Youth Council, the Rilem community, for the opportunity to present. Thank you.